Buddy, I'll begin to discuss here the another set of theory, which is all about the types of graph. In a types of graph, there will be at least 200 plus or more and more. However, we'll begin to run through about 30 types of graph only. So there will be a null graph. For null graph class, it is a graph that has no vertices and no edge. Essentially, it is an empty graph, meaning there are no points vertices to connect. This type of graph is theoretical, used to describe situations with no data or relationships to model. So that means to say, class, you don't have any vertices, you don't have any edges in your graph. That is really a null graph. Okay, let me just drink water. And for empty graph, this is different. It is a graph that contains vertices but no edge. Although the graph consists of isolated points or vertices, there is no connection or relationships between them. This type of graph is useful in theoretical studies and in situations where we start with a set of elements but no connection. In terms of this one, how can we work on with this here? For example, there will be set of nodes for A, there will be set of nodes for B, there will be set nodes for C. That is actually considered as empty graph. Now, trivial graph is the simplest form of a graph containing only one vertex and no edge because it consists of, excuse me, of a single vertex. There are no connection edges possible or isolated vertex. It is considered the smallest possible graph and it has a degree of zero because there are no edge. So what does it mean? Say for example, we only have A that is a trivial graph or isolated graph. That is how it works. Now, we also um okay. An undirected graph is a type of graph in which edges have no direction. In other words, if there is an edge connecting vertex A to B, you can traverse it in either direction. The edges represent mutual relationships between vertices, and there is no predefined start or end for each connection. So that means to say this one is considered as undirected because A to B or I to J is connected and J to I is connected also bidirectional. For directed graph, also known as digraph, consists of edges that have specific direction. Each edge is an ordered pair of vertices and the direction is indicated by an arrow. This means that if there is an edge from vertex A to vertex B, you cannot traverse from B to A unless there is a separate edge pointing in the opposite direction. That means to say that there will be A, for example, then there will be a B, and if our edge is A going to B, so therefore A is adjacent to B, but B is not adjacent to A. That's how it works. Now for disconnected graph, in disconnected graph, it is a graph that contains at least two vertices that are not connected by any path. In other words, there are isolated components within the graph that are not linked to other parts. For instance, a disconnected graph may contain many, excuse me, multiple subgraph, each of which is a connected graph in itself, but these subgraphs are connected to each other. What I mean is, for example, we have here A to B, and they are connected to each other, then there will be C, which is not connected either to A and B. So they are considered as disconnected graph. And for regular graph, it is a graph where all vertices have the same degree, meaning each vertex is uniform, connected to the same number of other vertices. In a regular graph, there is a uniformity in the number of edges each vertex has, making it a special case of both connected and unconnected graph. The degree of each vertex in a regular graph is k. So say for example, 1 is having 3, 1, 2, 3, and 4 having 3, 1, 2, 3. So this is actually a regular graph. That is how it is being represented. There will be a complete graph. A complete graph is actually a graph where every pair of distinct vertices connected by a unique edge. In other words, every vertex is directly connected to every other vertex. For a graph with n vertices, that is actually n vertex. Let me just update that one because why it is being represented as like that. Okay. So that is actually n vertices. A complete graph has n minus times n minus 1 over 2 edges in an undirected graph. In a directed graph, each pair of vertices will have two directed edges. So that means to say, class, for example, if you have five particular nodes, so 5, you'll begin to calculate that one. 5 minus 1 divide 2. So it will become 5 times 4. So it will become 20. 20 divide 2, it will become 10. So there will be an expected 10 edges for our particular for complete graph. In your A, B, C, D, and E. So there will be at least a 10 connection for this one. 1, 2, 3, 4, 5, 6, 7, 8, and whatsoever. But as long as it will have 10 edges, that is complete graph. Okay, that's how it will be calculated. For cycle graph, it is a graph that forms as a closed loop or a cycle. It is a type of graph in which each vertex is connected to exactly two other vertices, and the graph forms a single continuous path. In a cycle path, the number of vertices is equal to the number of edges, and there are no additional branches or loops. So when we say a cycle, if you will be to go ahead and make a traversal, I mean searching. So from number 4, it will go back to 4, 4, 5, 1, and 4. That is considered as a cycle graph. So therefore, in your cycle graph, there will be definitely it is actually having a cycle in terms of the connection. That means to say from going to that direction, from that direction going to that direction, there will be redirection. For example, you'll begin to go back into that specific position. Now, cyclic graph is any graph that contains at least one cycle. Many, it can have one or more cycle. A cycle occurs when you can start at a vertex, traverse through a set of edges, and return to the original vertex without retracing in any edge. Cyclic graph can have multiple cycles and may contain non-cyclic components, making them more complex than a simple cycle graph. So in a simple cycle graph class, since here then in a cycle graph, meaning that each vertex is connected to exactly two other vertices, and the graph forms a single continuous path. So meaning one cycle here. But for cyclic graph, it can have one or more cycles. So that's the differences. Now for a cyclic graph, and a cyclic graph is different. In such graph, there is no way to start um there is a way to start at the vertex, traverse through edges, and return to the same vertex. Directed acyclic graph are widely used in scenarios such as scheduling, representing hierarchical structures, and in various algorithms like topological sorting. In acyclic graph, actually meaning that we're actually having no cycles. So that means to say, from node A, it will not go back to node A. Also, so how does that work? Say, for example, A, then B, and C. So it is a cyclic if this is like this. If they are connected to each other, A to C, it will become a cycle, okay? Now, bipartite graph. For bipartite graph, it is a graph in which the set of vertices can be divided into two distinct sets, such that no two vertices within the same set are connected by an edge. All edges in a bipartite graph must connect a vertex in one set to a vertex in another. So, bipartite graphs are important in modeling relationships such as those between users and products in a recommendation system, or between task and workers in scheduling problems. What I'm trying to say here, for example, there will be a column A and there will be column B. Each of the column, there will be a node 1, 2, 3. And here, there will be 4 and 5. So it will be a bipartite if 1 is connected to 5, 2 is connected to 4, 3 is connected to 4. Either of that, that is considered as a bipartite graph, meaning that 1 cannot be connected to 2, 1 cannot be connected to 3. They actually can be connected to the other set or another column. That's how it worked then. Now, for weighted graph, it is different. It's a graph in which edge is assigned a weight. which typically represents a cost, distance, or time between the connected vertices. The weights on the edges are numerical values, and they are used in algorithms to find the shortest path, with a minimum spanning tree or other optimization task. Weighted graph can be either directed or the undirected graph, meaning, for example, from A going to B, there will be a certain number of 10. That's how it works for weighted graph. Simple graph, it is a graph that has no loop or multiple edges between um the same pair of vertices. It is an undirected graph where each pair of vertices is connected by at most one edge. What does that mean? So for example, we have A, we have B, we have C, and we have D. It is considered as a simple graph if they are connected to each other like this, A, B, then B, like that. And there's no loop. When we say loop, no mirror, like A to A, B to B, C to C, and D to D. That's how it works. That's what I'm trying to say for a simple graph. This is actually simple since they are connected to a different node, which is really not a mirror to itself. Okay. For multi-graph, allows multiple edges between the same pair of vertices. Unlike simple graph, multi-graph can have more than one edge between two vertices and may also allow loops, edges that connect a vertex to itself. What is trying to portray here? A to B, for example, they are connected with having weights of 10, and there will be another edge which having value of 20, and there will be another loop here for 5, for example, B to B. That's actually how multigraph work. Now, what is planar graph? Planar graph is a graph that can be drawn on a plane without any of its edges crossing each other. In other words, it is possible to lay out the graph in such a way that no two edges overlap, except at their endpoints. Planarity is important in graph drawing and circuit design. So what we are trying to say here. So say for example, A, B, C, and D. Um, it is planar if just like this. But it is not planar. I'm sorry, it is not planar if there will be an intersection. So meaning they overlap to each other. That's not considered as a planar graph anymore. Now for there will be a finite graph. When we say finite graph, it is a graph that has finite number of vertices and edges. Most practical graphs are finite as they represent a real world networks with limited nodes such as social networks or communication system, meaning define deterministic. For example, n is equals to 5, there will be a 5 vertices. That is actually a finite graph. Now, infinite graph is a graph with an infinite number of vertices or edges, while theoretical infinite graphs can model concepts like infinite networks or process that involves an unbounded number of interaction, meaning that there's no end in terms of this infinite graph. So there's no such termination. It's not deterministic. So for example, um you will begin to deal with infinite. It is actually recursion until your memory will crash. That's actually infinite. Now, star graph. A star graph is a type of graph in which one central vertex is connected to all vertices. So, but no other edges exist between the outer vertices. The structures looks like a star with one central point connected to multiple outer points. How does that mean? For example, A, this is the center point that is connected to another vertex B, that is connected to another vertex C, that is considered as a star connected to another vertex of D. As long as they are connected into that middle point, that is actually considered as a star graph. It's not like the star that you are trying to create during Christmas season. No, that's not star graph. Now we also have tree. A tree is a special type of graph that is acyclic since contains no cycle and connected. So a tree with n vertices always has n minus 1 edges. It is widely used to model hierarchical structures such as file system, organizational charts, and decision trees. So in our tree data structures, we're able to work on that before. So it is actually considered as a graph also. Now, we also have spanning tree of a connected graph. It is a subgraph that includes all vertices, the original or a graph, with a minimum number of edges needed to connect them. A spanning tree does not have any cycle, and it is a fundamental concept in network decision and optimization. So, meaning there will be no cycle for this one. When we say spanning tree, say for example, we have A, B, and C, and they are connected to each other. So spanning tree does not contain any cycle. So therefore, from that one, either it could be like this: A B to A C or C B. That is considered as a minimum. I mean spanning tree already. There will be two types of spanning tree: a minimum and maximum. But we'll begin to focus into the minimum spanning tree in the future. So there will be complete bipartite graph, meaning it is a graph where the set of vertices is divided into two disjoint sets, and every vertex in one set is connected to every vertex in another set. But there are no edges between vertices within the same set. This is a special case of bipartite graph, meaning that if you have A and B set, then 1, 2, then 3 here, and 4, and 5, for example, meaning must be complete. One is connected to the two um to vertex there. So that's actually complete bipartite graph. Now we also do have here directed acyclic graph. When we say that directed acyclic graph, there will be no cycle. However, they do have a direction with no cycle. This type of graph is used in various applications, including scheduling problems, data processing pipelines, and representing hierarchical structures like family trees or task dependencies. What I'm trying to say, A connected to B, connected to C. However, there will be a direction. So A goes to B, B goes to C. That's actually one directional, and of course not containing any cycles, since that is actually a cyclic graph. Now in hypergraph, it is like your teacher, Sir Max. It is a generalization of a graph where an edge called a hyper edge can connect any number of vertices, not just two. Hypergraph are used in fields like database theory, computer science, and combinatorial natural optimization. What I'm trying to imply, say for example, as what we have learned, A is adjacent to B alone. But here then we can use one edge which can connect three vertex already. A A goes to B and goes to C. That's actually how does that work. Now, K-regular graph. K-regular graph is actually um is a graph in which every vertex has exactly k edges. This type of graph is often used in network theory where uniform connectivity is desired among all vertices. So here then there will be a set of k number, just like in n equals n array 3 for our three data structures. K is equals to 3. So therefore there will be three connections in each nodes, for example. That's how it works. Now, okay. Now, edge-weighted graph. An edge-weighted graph is a graph where each edge has an associated weight, typically representing the cost or distance or capacity of the edge. These graphs are particularly important in optimizations problems, such as finding the shortest path or minimum spanning tree. So, meaning that there is a specific number to each edge. And for vertex naman, a vertex-weighted graph is a graph where each vertex has a weight associated with that, often used to represent costs or capacities at the vertices. These graphs are used in problems like network flow and resource allocation, meaning that within the vertex, aside from there will be a representation of A, there will be another value of number. That is actually can be utilized when you will begin to learn in the future in terms of your artificial intelligence course, that there will be you will begin to deal with A star algorithm, that there will be for A star algorithm, H of n plus the J of n, like that, that you'll begin to deal with that in the future then, okay? So in terms of subgraph, a subgraph is a graph formed from a subset of the vertices and edges of a larger graph. It includes a selection of vertices and edges, but maintains the original connections between them. Meaning, subgraph is actually, in our particular graph, what will be the There will be a subgraph 1 to 8. Accordingly, that's how it gonna be represented. Now, a sparse graph. When we say sparse graph with relatively few edges compared to the maximum possible number of edges, resulting in a low edge density, this means that most vertices are not connected to every other vertex. That means to say from if we do have vertices here, A, B, C, and D, it is considered as a sparse graph is like this. There will be few edges only. Now, for dense graph, it is different. Where the number of edges is close to the maximum possible number, meaning most vertices are connected to many other vertices. This creates a highly interconnected structure with a high edge to vertex ratio. What does I'm trying to imply? A, B, C, and D for dense graph, they're absolutely connected, populated, for example, like this. So that's actually dense. Now, triangular graph. It is a graph in which every edge forms a triangle with its two adjacent edges. This type of graph is commonly used in chemistry to represent molecular structures such as benzene rings in organic chemistry. That means to say, class, that like this, it is a triangle, triangle here, triangle, that is triangular graph. That's how it works. So those are the representation of the types of graph, and I hope so that you were able to learn something about this. Thank you so much, everybody, and see you in the next video. Thank you. Bye bye.